Mehta sir, good morning.
Good morning, Tushar. How are you?
I'm good, sir. How are
you? Very well, very well.
Okay, so we have architect Joy Mondal with us, who is the speaker for today. Joy, this is architect Premendra Raj, sir. He is the supervisor of our school.
Good morning,
Joy.
sir.
Hi, Joy.
Lovely to meet you.
Good. Very good to see you, Joy.
So, sir, we'll just wait for a few more minutes, like till 10:05,
yes,
and hopefully a few more people will join in, and then we can start.
Yeah. Sure. So, Joy, what all do you do?
Sir, I run a design computation practice.
Okay.
We offer parametric consultancy to architects across India.
Okay, very good.
And I, at the same time, also teach as a visiting faculty at SPA Delhi and CEPT University.
Oh, wonderful. Very good. So, where are you based? In Delhi or Ahmedabad? Where are you based?
No, I am based out of Delhi, but currently I'm in my hometown, Calcutta.
In Calcutta. Okay. Yeah. These days, the location is not that important. What is important is how you can access wherever you want to go. No, true. So artificial intelligence, one factor is this also now. It has proved a point that you don't have to be physically there. Somebody else can take care of the communication. Face to face can be with artificial intelligence. Good, very good. Very good.
Sir.
So when you teach at SPA, what do you do? It's a one-off one lecture, or it's a scheme of things with maybe 5 lectures? You make a sequence, some kind of a test. Yeah.
I teach an entire subject. They have modified their syllabus to include applications of computation in 3rd year.
I see.
Earlier, it was an elective. This is back in 2015, but by now they have modified the syllabus to have 2 different semesters dedicated to that particular subject.
Okay, so third year is a class where you bring in this.
Yeah.
But don't you think that students coming out of 10+2 are quite well versed with the concept of artificial intelligence? Of course, computation is a subject which naturally you have to understand many other subjects before you can get into computations, mathematics, geometry, many things.
You're right, sir. When I was studying, I got to know of all of this in my 5th year, my final year of studies. But now, even the first year students sometimes contact me asking me about different things that they can do.
Absolutely. Because you see, that is what I saw in IT education when they introduced MTech program in IT. There was a situation, and I was one of the regulators of that the syllabus of MTech, syllabus of BTech final year, syllabus of BTech first year, they were identical. Because it was a generation which was moving towards that. And we were introducing a subject to the students. So, because this is how it filters down, because these things have to become part of life rather than a knowledge-based thing. They have to be ingrained in you, like writing. So you learn ABCD in maybe 1st standard or 2nd standard. So all this has to start from there. And that is how I look at it.
Exactly, sir. And it is my belief that instead of letting the folks from IT dictate how AI will play a role in our industry, we have to undertake the initial set of research and be in charge of the narrative ourselves.
Absolutely. It is our vocabulary and our handwriting, I always say. So our style of communicating and our own vocabulary, our own alphabets. And that will make the difference. Because otherwise, like in AutoCAD, we got a mechanical engineering software being used in architecture. So we didn't start with architecture. The AutoCAD is actually a mechanical engineering tool. So that gets mixed up. If we don't do it ourselves and we let others do, and then try to apply whatever is applicable. Then it is a very confusing state.
Yes,
Good.
Okay.
Good. I'm very happy. I'm very happy that you have come in. Yeah.
Okay, so I think we can
my
start
pleasure.
with the webinar now.
Yeah, Tushar.
Yes. So very good morning to all and welcome to the 20th edition in the Every Friday webinar series, a platform for young minds to express their ideas. So my name is Architect Tushar Mondal and I'm a teaching faculty at the Periyar School of Architecture, New Delhi. Today's webinar will be discussing artificial intelligence in design and will be presented by architect Joy Mondal. So before introducing the speaker for today, I would like to honor architect Tremendra Raj Mehta, who is our supervisor along with his partner. He is also the former president of the Council of Architecture. Sir, if you would like to say a few words to motivate us today.
Yeah. Welcome, Joy, to this 20th in line in our series of what we look at this particular forum is that if young minds have an idea to solve an existing problem, or they have something to deal with the future of people in this world, and they have some thought, some idea, which if initiated could resolve certain solution. One, they could provide us quicker answer to a problem which Herto had been taking a long time in making studies, analysis, computations, and so on. And second is some original thinking and to simplify what we think is very complicated at this moment, or if we are not able to get an answer to a problem for a long time. So the idea is that if the younger generation has something to say, why they should wait till they come into responsible position. The idea itself, if it's with us, we must check it, and we must try to develop it, and we must share it with those who matter, so that these ideas could be recognized at an early stage, and someone could help them, be it government authorities, be it institutions, help you develop this. And Periyar School is committed to make that connect between those who have an idea and those who wish to pursue new ideas. So this is the endeavor we have, apart from many other things, new initiatives. Tushar has been pursuing it, and it is 20th in the series. I must congratulate him and all the speakers who have been part of this. And I welcome Joy here on the 20th in this line, and welcome all the participants who have taken time off to join us to share their critical thinking along with the new idea which will be presented to them. And I invite them also to come out with their own ideas and join us whenever they want to. Thank you and welcome once again.
Thank you so much, sir. I also welcome architect Brahmadev Dahiya and architect Prakriti Mehta, who are also supervisors for the school. Welcome, sir and ma'am. So now I will introduce the speaker for today's webinar, architect Joy. So Joy is a computational design consultant and the founder of Research Lab. An alumni of Jadavpur University, Joy's research focuses on automation of design processes and employing AI in design. He has developed two Grasshopper plugins, namely Elish and Chimney. He has also actively taught subjects related to artificial intelligence and machine learning in architecture as a visiting faculty at SPA Delhi, CEP University, and through various workshops. Today, he will be talking about using artificial intelligence in design. I would request Joy to now begin his presentation. It's a request to all participants to keep themselves muted for the duration of the presentation. We will have a discussion and question answer round at the end when you can ask your questions. Thank you. Joy, you can now begin with the presentation.
Thank you, Tushar. Thank you for the introduction, and thank you for the.
Let me interject, Joy. Sorry,
Yes,
pardon.
sir.
Let me share with you. Once he said that you are from Jadavpur University, I cannot resist but to make a mention that 25 years ago, this issue of artificial intelligence was discussed by none other than a professor of Jadavpur University, Mr. Suman Chakravarti.
Oh, yes. He was my faculty.
You remind me.
Yes, sir.
Yes. Oh, is he still there? If he's still there, please
he's not active.
Regards.
He's not active anymore. He has retired. I was amongst the last few batches that he taught.
So please convey my regards to him, and if you can connect me to him, I would be very happy, because you remind me of his initiative sometime when people were not even thinking about this. Yeah.
Sure, sir. I'll do that. I'll connect you with.
Yes.
We call him SC, sir. I'll connect you with
Yes.
SC,
Somen Chakravarti. I remember him very clearly, and
Yes.
very fond memories of my interactions with him. Yeah.
Certainly, sir. I'll do that.
Yeah. Please go ahead.
All right. Thank you, sir. All right. So I am going to talk about where AI is placed with regard to architecture, and what are the few research works that we at Research Lab have been working on. And I'll try to give 3 examples of 3 different scales of project, or 3 different scales of ideas. But before I get into that, it is important to contextualize where AI has developed, or at which nascent stage AI is in our domain. Now, to get into that, let me start with this particular image, which may seem like a game of chess, but it's actually being played by the gentleman on the left, one of the chess grandmasters, Garry Kasparov, and the computer on the right, which was at the time developed by IBM in 1997. This was the first time a machine had defeated a chess grandmaster. And at the time, it led to a pretty significant pop culture phenomena of man versus machine. And there were all kinds of predictions of wonderful things, apocalyptic things, etc. and etc. But the key thing to keep in mind about this event is that the program wasn't really intelligent, so to speak. The program quite literally searched through all possible movesets and picked the moveset that worked out the best. So it used efficiency of the computer to run a brute force search to figure out the best possible one. Not really intelligent, but effective. Now, if we jump a decade later, in fact, more than that, in the mid 2010s, now IBM was, of course, replaced by Google as the pioneer research company in computation, and they developed an algorithm called AlphaGo, which played the game of Go, and the board game is displayed in the image. Now, at first glance, it may seem like, it looks pretty simple. There are white pebbles, there are black pebbles. What is the big deal about it? But the staggering thing about this is that in this particular game, the number of possible move sets or combinations is greater than the number of atoms in just the known observable universe. So you can imagine the quantum of searches the computer would have to go through if it literally uses brute force to go through all of them and run a sort algorithm and pick out the one that works best. Even though computers become faster and more efficient exponentially, still don't have computers to run such a set of search instantaneously, which is why the developers of this game the algorithm that played this game had to rely on pattern detection, which is quite literally the first example of the use of AI in solving a game or gamification of a scenario. And the algorithm was trained to mimic how humans play by watching videos of humans playing against each other. And they used a database of around 30 million moves. And this was played against one of the best players of the game Go by the name of Lee Sedol. And it happened to defeat Lee Sedol in best of 5 series. And not only that, because it began learning the movesets without any bias that us as players have. And the biases are more often based on our tacit knowledge or our experiences. Because the computer, the AI, didn't have any bias fed into it. It detected certain patterns which were incomprehensible to us. And it did end up playing such moves in the game, which at the time the commentators thought implied that the AI has gone kaput and it's not making sense anymore. But at the end of the game, Lee Sedol ended up commenting that it's not a human move. And I've never seen a human play this move. And ended the comment by saying he found that move to be particularly beautiful. And this whole business of gamification took another quantum jump a couple of years later when AlphaGo's successor, AlphaGo Zero, was developed. And in this case, it wasn't taught with the videos of humans playing against humans. Keep in mind, the amount of videos one can gather of humans playing against humans is limited, is finite. So what the developers of this version did was they taught the neural network the rules of the game, and it simply started playing against itself. So there's no video needed, there's no amount of data collection that's needed. It knows how to play it, and it starts playing against itself. And within 3 days, I think it ended up playing more than 1 million matches with itself. And at the end of just 3 days of training, it played its predecessor, that is AlphaGo, which you saw in the last slide, and it defeated AlphaGo by a score of 100-0. Quite a staggering score line, which, by the way, remember, AlphaGo had defeated the best Go player at the time. Now, this is where the contextualization becomes important. Back in the 1990s, Frank Gehry had to hire a CATIA expert by the name of Rick Smith. At the time, CATIA was predominantly used by the aerospace industry and the automobile industry for not only digitally representing complex shapes, but also rationalizing and generating shop drawings of the same complex shapes. At the time, the software used in the architecture industry did not have the capabilities to represent such complex shapes. Forget about rationalizing or automating generation of construction drawings. And at the time, in the early 1990s, it took a star architect with substantial resources to hire an expert from a different industry to start constructing buildings such as the Barcelona Fish and Guggenheim Museum, the one in Bilbao. This happened in early 1990s. From that time, it took almost 17 years for Grasshopper to be released in its nascent beta version. So it took almost 17 years from someone with incredible amount of resources to adapt software from another industry to getting to a plugin or a software which was predominantly developed for designers, to get to a software which was adapted by designers and architects all across the board. It took 17 years for that evolution to come to fruition. Now, the introduction of AI in architecture right now is in the Barcelona Fish Guggenheim Museum stage. However, I'm optimistic given the wide-scale access to information these days, and of course, the game changer in the form of internet, in how it helps in access and distribution of information. I am certainly hopeful that it won't take 17 years from now to reach to a software dedicated to architects which directly uses AI. Having said that, it is important to keep in mind that most of the examples related to the use of AI deal with stock price prediction, product suggestions on Amazon and other shopping websites, music recommendation by Spotify. In fact, even the text that we type in WhatsApp on our mobile is an example of AI, where it's with each key being tapped, it's retraining itself to our customized likability. So if I type the alphabet A, the suggestion that you will receive will be different from the suggestion that I will receive, because through the use of the keyboard, so to speak, for months and months, if not years, the keys that I have typed has been different to the keys that you have typed, and which is why the training has been different. And because the training has been different, those kind of suggestions that each of us get would be different from one another. But till around 1998, artists and architects were very apprehensive about the whole idea of AI because, as I said, most of it had to do with either gamification or with prediction of very objective uh, phenomenons, very objective systems. All of this changed in 2018 when something to do with the emotive side of life came into light, and it had to do with AI. In 2018, Christie's, which happens to be one of the most famous art auction houses, auctioned this portrait, and it was sold for around $500,000 after being offered for around $50,000. Now, the significant thing about this portrait, as you may have guessed from the slide, is that it wasn't drawn by a human. It was drawn or generated or statistically crunched. Which phrase or word you want to pick is up to you. It was done so by an AI algorithm. And the way it did so was that the algorithm was fed 15,000 portraits from, if I remember correctly, 14th century to the 20th century. And the algorithm was equipped to detect edges such as our cheekbones, our eyes, our noses, hairline, change of clothing, texture, etc. And it learned all that meta information about all the 15,000 portraits. And once it learned all that information, its job was a very critical job that is also very applicable to architecture design as well. Its job was to create a new portrait which was similar enough to look like a portrait, yet had to be different enough to not be considered a copy, right? A very fine balancing optimization act that the algorithm had to undertake. And cheekily enough, the formula which helped them to execute this optimization, this balancing act, is actually the formula with which this painting is signed off. It's not signed off by the name of an artist. So this was quite a seminal work at the time. And then a lot of interested artists and architects jumped into the bandwagon of exploring the use of AI in our field. And then these are certain examples of combining paintings of some of those famous Indian artists, such as Jamini Roy, Jogan Chaudhary, etc., and etc., Souza, M.F. Hussain. Now, where at this moment is this applied in architecture or in the generation of images for architecture? So this would be the first example, and this works as an example of graphic generation. This is being used as something called style transfer, where the algorithm picks up the style of an image. For example, here the painting of a small Italian town, and it projects that style onto a container object or a content image. As you can see, the gray hatch has been rendered in the style of this particular painting. And this doesn't take much time, it takes about a couple of minutes for this image to be generated. And this can be applied to a variety of architectural diagrams. Now, if you combine Doshi's Ahmedabad Gufa, which has circular plan, with Korea's Sabarmati Ashram, and you try intermixing the two, look at the output of how Doshi's design is visualized when pixelated. It kind of produces the kind of plan that a lot of humans, a lot of architects would produce, where the circles are pixelated. And not only that, it has automatically picked up the idea of running walls from Korea's design of Sabarmati Ashram, and as if to introduce that in Ahmedabad Gufa's pixelated version, the algorithm has automatically added these extended freestanding walls from the plan itself. Quite a staggering feat, since we haven't explicitly told the algorithm to do anything like that. Certain other examples, one of the most fascinating output is the one towards the right, where it automatically understands that one of the key features of a Palladian villa is the steps that lead up to the closed spaces. And again, it automatically picks up that that is indeed the not the one of the distinctive features, and it adds those steps around uh, the plan of Ahmedabad Dikufa, almost in a way that, you know, the great Charles Correa introduces steps in most of his designs. And then there are other ways of sort of exploring this. I won't get into much depth because of brevity of time. One can always change simply the gradient of the content image and keep the style image the same, and we get a whole different variety of output with regard to the direction of the brush strokes. And of course, it's not restricted to one particular painting. Depending on which material or which medium the style image is, the output will be changed accordingly. So this is very useful at this moment in time in generating mood board images or generating concept diagrams, where if you have to go from one project to the other, or within a project, if you have to try different mediums of representation, one may not necessarily have to sit and draw them again and again and again. If there is, if within a practice we have an architect who's really good at painting or sketching, then one can pick previous works of the said employee or architect and use those as a style image to generate presentation diagrams or for newer projects or for newer material for the same projects. You know, because most of the times the expert in the practice or the expert in the school will not be available to render his or her service for all the projects across the board, right? So in those cases, these things really help us in determining how this may work. Now, but this does lead to a rather fundamental question, that who owns these output? Is it the AI algorithm? Is it the person who is feeding the diagrams? Sorry, the images? Is it the owners of the original images? Or is it a combination of the AI, the person who's feeding them, and the owners of the original images? That is a question that is yet to be answered, not only from the perspective of legality, but also philosophically, we are yet to address that question. Now, I did run an experiment with this. I used an image of Howrah Bridge from Calcutta and used a painting from the internet as the style image, which gave me an output such as this. And I posted it on Facebook, and alarmingly, no one could figure out that this is not really painted by me, that this is painted by a machine or generated by a machine. And I got wonderful comments related to that. Now, of course, I haven't revealed yet to them personally that this is not painted by me, but it kind of puts into perspective qualitatively how humans will perceive such an output. It's, as you can see, these are my dear friends. They know the kind of painting that I am capable of, which is not wonderful. Let me be, in the spirit of candor, let me reveal that. But they didn't really blink an eye in believing the fact that this is made by a human. And they couldn't really tell that something such as AI is kind of in the back of this. Now, let me move to an example which is more to do with 3D form finding. And this method was developed last year along with a few volunteers / participants from University of Southern California and I. The idea is this, that currently, if we have to iterate different,
Joy, sorry
yeah,
to interrupt. Did you change the screen because the screen visible to us is still the social experiment screen?
I did. I have opened.
No, so the visible screen is different. It's still the previous screen from which had the painting.
Sorry, my bad. Yeah, I have changed the screen. Is it visible now?
Yes, yes, it's visible now.
Okay. Yeah, thank you for that tip. Now, as I was saying, the method of iterating through variations of a 3D form right now is done by making visual scripts in Grasshopper, or explicit scripting through a traditional programming language such as C Sharp, or one of the new ones such as Python. The problem with that is that those who have an inclination towards algorithmic thinking, those architects and designers, lap it up pretty easily. But if you look at the entire industry as a whole, then the barrier to entry, the difficulty in learning these techniques and tools is so high, coupled with the fact that most people are not naturally inclined towards addressing a problem through the language of coding. These two factors mean that the idea of Grasshopper or visual scripting or algorithmic iteration of 3D forms is right now limited to only a certain set of people. It hasn't become as prevalent as probably the authors of Grasshopper would have liked it to be, which is where I believe that AI can come into picture. It can be a one-click solution. The challenge for this uh, interrogation was to do away with explicit parametric rules and use AI to generate variations of 3D uh, models by implicitly learning its spatial feature. Where by that I mean where walls are present, how walls are interacting with each other, where do we have a roof, where do we have a platform, a podium, etc. and etc. Now, the way this works is that we discretize our 3D geometry to generate an image representation, and then there are algorithms which take an image and automatically produce variations of the image, pretty similar to what the art example did. It will generate images which are different enough not to be considered a copy, yet similar enough to be not too abstract. If you uh, skip the abstraction control, then it kind of becomes something full of noise. Now, to talk you through the steps, we underlay a grid on our 3D and we detect the unique cells or the unique grid cells. And once that is detected, those unique grid cells are given a pixel value from 0 to 255, and those values are repeated, and we get an image representation such as this. So for example, the left corner is empty because over here the left corner doesn't have any information. Now this image is then used by the AI algorithm to produce similar looking yet different image output. Now this learning of the image and producing different output, when done for let's say 1,000 iterations, produces a lot of gibberish such as this. But within this gibberish, we can see in some options certain walls are beginning to emerge. There's a certain sense of pattern that is beginning to emerge in these cases. And then if we increase the number of iterations, we can see such smooth, exquisite output. Now keep in mind, absolutely nothing was mentioned explicitly. We didn't tell the AI algorithm that these are the number of walls we want, that the walls and the roof surfaces need to be watertight, the plane and the ground needs to be at the ground, the plane and the ground needs to be watertight with the walls. We didn't say anything such as that. No rule was mentioned. All we did was make an example 3D, and the rest was taken care by the algorithm that we developed. Now, this, in my opinion, will be a game changer where we will no longer need to literally mention rules that can generate a 3D form, because a lot of the time the interrogations are rather intuitive in nature, right? It's rather similar to doodle making. We follow our instincts and sketch, and then later on it gets 3D modeled, or some people directly start 3D modeling if it suits them. And not a lot of the time do we have absolute clarity about the rules that lead to the configuration that we have on our sheet or on our screen. So this, in my opinion, will be a game changer, and it can also be used with multiple input 3D aggregates, where it will learn the spatial distribution of the individual input aggregates and generate variations which have a combination of the spatial distribution of each of the multiple input aggregates. Of course, the weightages of these can be varied, but those are nuances that are best left to a discussion of a different time. So again, just to repeat, the 3D model is discretized by underlaying a grid and figuring out the unique cells, which then helps us produce a black and white pixelated image corresponding to the unique cells. And then that image is used by the AI algorithm to produce similar yet different images, which is then again translated back into the 3D form, which helps us in achieving 3D differentiation. Now, for the last 5 minutes, I will move on to an example which is related to analysis of cityscapes. And before I begin that discussion, let me first say that in traditional programs, we mention the explicit algorithm, we feed the input data, and it gives us certain answers. Whereas in the case of neural networks or machine learning, we feed a whole bunch of example data, which have both the input and the output, and the AI algorithm appropriates the rules. In other words, it appropriates the algorithm, which is why it's at times is called as a black box example. Now, we do know the sorry state of affairs when it comes to safety in many Indian cities, and predominantly the news covers the crimes committed in cities against women. But we have to, if you look at the statistics objectively, while the nature of violence against men is not sexual predominantly, but the nature of the amount of violence against men has also been increasing by many folds over the last decade. And the way safety is discussed right now is that we talk about a variety of active measures such as patrolling, CCTV cameras installation, installing lights on streets where we may have dark patches, fast grievance addressal, etc. And we also talk about long-term measures such as introducing sensitivity courses in our school. These are all great measures, and all of these need to be undertaken. But many a times in our discussions, we forget the fact that the canvas on which all of this happens is the urban fabric. Now, we need to have a conversation about predicting the safety perception of some of the cityscapes that we see around us. In fact, why just some? All of the cityscapes around us. And this is a project called Safe or Not, which we are in the process of developing at the moment. I'll give you a sneak peek. The hypothesis is the following. We see and perceive outside our window, through our eyes, or while we walk through a city, through 4 algorithmic understandings. One is compositional segregation, where when we look outside, We kind of segregate. This is the patch where I see trees. This is the patch where I see roads. On the road, this is the patch where I see some people, so on and so forth. On top of that, we also add object count, particularly to animate objects, such as if I see a patch of vehicles, I would like to know if there are 3 or if there are 30. If there are 3, I can wait for them to go to cross the street. If there are 30, probably I won't be able to cross the street right here. It's better suited to walk a bit and let them go past before I think about crossing the street again, so on and so forth. At the same time, color is a wonderful proxy of the temporal nature of our day, dawn, afternoon, bright. It also tells us about weather. Gloomy sky means that rain might be incoming, and then dusk and nighttime. And then we also have spatial semantics, where it's not just I see a building. What is that building? Is it a shopping mall? Is it a church? Is it a school? Is it a warehouse? And each such information subliminally tells us something new, and based on our past experiences, which is different for all of us, how we perceive that space changes, how safe it is, how beautiful it is, what memories it triggers in our head, all of that is different for each one of us. Anyway, the compositional segregation output looks something like this, where some of the patches of different components are highlighted in different colors, and it gives us a numerical output of the percentage of pixels occupied by each of the compositional elements, and it includes sky, building, tram, signages, etc., 20 different. We've all seen output of object count. It sort of highlights how many people it detects, how many vehicles it detects, and it also gives a confidence score, such as this, that it's 99% sure that this indeed is a motorcycle, so on and so forth. Of course, I don't need to speak much about color detection. It's pretty self-evident. And we also have something called spatial semantic, which also identifies the image in a descriptive manner. For example, this image at the bottom is called a cottage. This one is an viaduct. This is a church at the bottom right. The top left is an industrial area. So this hashtags, which we understand subliminally, also tells us a lot about how we perceive the space. Now, these 4 things are combined to represent how we look at a city. And beyond that, we have gotten 10,000 different photographs of cityscapes rated by different groups of people. In this case, men, women, and transgender. Right now, the output of men and women are ready to be speculated upon. We are yet to accumulate as many data points for transgenders as we have for men and women, because access to them is predominantly through NGOs, and it's taking slightly longer than we expected. Anyway, these are the certain primary correlations we understood. Apparently, presence of sky, sidewalk, and traffic signs increases the sense of safety. Pretty intuitive standard stuff, but surprisingly, the presence of a motorcycle or a rider who rides a motorcycle is one of the biggest deterrent of the feeling of safety. Now, the method of this is that we have a bunch of images, 10,000 in this case, and then we extract the parameters through the 4 algorithms I discussed. Parallelly, we get the 10,000 images evaluated by a crowd, in this case, 3 groups of people. And then
Maggie.
yeah,
Sorry for the interruption. Yeah, Jad, please continue.
Yes. And so while the parameters are extracted through the 4 algorithms from the 10,000 images, and parallelly the images are evaluated for safety rating by a whole bunch of people, those 2 are collated. So the evaluation is the output, and the parameters or the feature extraction is the input, numerical input. And then those two set of values are used to train a neural network, which can then predict the safety perception of different cityscapes then on. So this is the kind of output we have at the moment. We can clearly see that if you look at the percentage distribution of the safety scores of male and female, the left side being unsafe and the right side being safe, you can see that the nature of the curve for male is towards the right compared to female, which means that of course men tend to feel safer than females. And if we kind of quantify this, the average safety score for male is 27% higher than the average safety score for females. And in as many as 92% of the cases, I mistyped this, the safety score for males is higher than the safety score for females. Now, then there are different matrices, but I won't get into any of that. What this will end up helping us in achieving is that it will help us run safety audits of neighborhoods, not only new designs, but existing designs as well, and understand and figure out pockets which would need immediate attention, not only through active measures of patrolling and installation of light or CCTV, but also in the way that area is designed. The urban design of that space would need to be addressed. And of course, this can also be used eventually as a design tool where it will be used as a plugin where you're making a 3D model of an urban scape, and you can assign the different points for which you need safety score. And once it gives you the score, you can play around with the composition. If you increase the sky view factor, what effect does it have? If you add more trees, what effect will it have? If you change the building type from commercial to residential, what effect it may have? Those kind of things will come into picture. With that, I would like to conclude my presentation, and I'll be happy to undertake any questions, address any questions, or get into any kind of discussion.
Okay, thank you, Joy. I think it was a pretty elaborate and well-explained presentation. So participants can now ask questions. If anybody has a question, they can either put it in the chat or you can simply unmute yourself and ask the question. In the meantime, I would also like to welcome architect Kamal Raj, who is the head of our school. Kamal sir, if you would just say like give your comments or views on the subject. Kamal sir.
Yeah, hi. Welcome
good morning,
everybody. Welcome everybody. So I joined a little late, but it was very interesting presentation. And this is this is what, Tushar, when you outreach the potential students, you should tell them that architecture education is not only about building today. It is, combined with the digital and AI platforms, with the, let us say, 3D visualization and imagination of architect. When they are equipped with the cutting edge technology, they tend to become leaders in the digital work or digital world or a world of the future. So this is what we need to communicate with today's students, potential students, that just making building and naksha pass karana is not just the aim of architects. There is much more to architecture and architecture education. It equips you for much more in life. So that's what I would like to say. And this presentation also points to this fact that, when imaginative people who are doing a three-dimensional, used to thinking in it 3 dimensions, when they use these tools, they stand ahead in the world.
Thank you so much, sir. So yeah, is there any participant who wants to ask a question? Then please feel free to go ahead. So in the meantime, I have a question from architect Prakriti Mehta, who unfortunately, ma'am, are you still here, Prakriti ma'am? Okay, so I can ask the.
Yes,
Okay,
I
yes, ma'am.
am there.
Yes, ma'am.
Yeah.
Should I ask on your behalf?
Yeah, I'll just ask the question. I may have to leave. I'm sorry.
All right,
But
ma'am.
yeah, thanks, Joy. It was a wonderful presentation. And I think there are certain aspects of AI which I think quite a few of us here may not be aware of, but were experienced it through the mediums, different means and mediums that you've shared right now, from paintings to designing to architecture to urban scale. So you've looked at different mediums and different scales as well. I had a question while you were presenting on women's safety and mapping for women's safety at an urban level. So that was an excellent example. At the same time, I think I would also want to understand how design thinking can be a future prospect of integration with AI, because specifically what I was interested to understand is that how people's participation can also be included as a means, as an extension to the process that you've looked at, with the help of AI itself. Because as I understand, and you can correct me if I'm believing it rightly or not, that it's the rules that you feed in, as you mentioned in that diagram, the rules that are being fed, are they not biased by the designer himself, or are they evolved out of also a process or an algorithm by the designer or whoever's working on it? Yeah.
Thank you for the thoughtful question. I am going to answer it in two different scales. One with regard to architecture consultancy, and one with regard to urban design. I would argue that when we talk about architecture, in a lot of the cases, we are paid to kind of play around with our biases of 3D aggregation. So the example of the process called deep isomer, which was the second presentation or the second bit of the presentation, would of course reflect our bias when we give the example 3D aggregate, and then it will learn that bias and reproduce certain aggregates which are similar yet dissimilar to that. So in that case, I guess introducing our bias is beneficial, because that's our unique way of solving that architectural problem, and we are quite literally paid to do so. But I would say the idea of urban intervention is more democratic than that. It's less personalized than architectural signature. In that case, I think the idea of crowdsourced data collection becomes vital. So let's take an example of what I envisage would happen in 5 years, 10 years time in terms of participatory decision making or design input. Right now, in many cases, not all, some do go an extra mile to include residents of the area where intervention is being designed for. Some do go an extra mile to invite them in the process right from the get-go. But in most of the cases, once certain ideas are discussed with the main stakeholders, then those are presented to the public and their feedback is taken. But with the use of AI, what's going to happen is, similar to what we are doing with safety, someone will develop a mobile a mobile app, and it will be distributed to the residents. Let's say they'll be simply asked, click the paths or areas in your cities or wherever you're traveling which you do not like. upload it. Click the parts that you like and upload it. Or even run a Google search, pick out the images that you like, upload it, dislike, upload it. And the algorithm will run the numerical analysis, automatically tell the stakeholders that, this is the kind of percentage distribution of composition or building types or color scheme that this area's residents do not like. Now that information from Jasola will be different compared to South Extension, will be different compared to Chandni Chowk. So we'll go hyper local in that sense. And this can happen before pen is put to paper, before design begins. We can have a 1 month, 3 month window where the residents are requested to use that app every other day. So that information is collected. So right from the get-go, we can begin with certain intel of what their aesthetic or design sensibilities are, which is such a difficult to capture otherwise, right? So how many people are you going to literally talk to? This process will, in my opinion, will democratize the idea of quite true representation of the sensibilities of the people living in that area. That is a specific case of the use of AI, but then there's also layers of Internet of Things and other such applications which I haven't covered in the presentation, so I won't really talk about those.
Thanks, Rohit.
Thank you, ma'am, for the question, and thank you, Joy, for the answer. Yes, is there any other participant who wants to ask? Then please feel free to ask the question. You can put it in the chat or unmute yourself and ask.
I want to ask a question.
Yes, please go ahead, Rohit.
Hi, Joy. I've been following your work for quite a while. You were my professor in Sushant once.
Oh.
And so basically, I wanted to ask you, and so when you talked about AI in your presentation for design, like there was showcase of GANs that merge two images or design to create a new image. But we have to keep in mind that there is a limitation of these softwares being designed by humans. So do you think there is a potential of creating much better designs if these softwares are sort of autonomous, or like they feel like design these softwares using AI and then they like create completely different designs which are like sort of beyond our control or like can't be manipulated?
That is a possibility. In fact, I would say even the presentation that you saw, the second one, where a lot of the output seemed workable, right? They had pretty straightforward, traditional orthogonal walls, straightforward roof system. But even in that example, I would say 10 to 25% of the output is just noise. Randomly scattered pieces of walls all across the grid, not really usable. That is, I would say, an undesirable feature of anything to do with computation of 3D geometry. These things we experience when we play video games. These things we experience as glitches, where suddenly you will notice that in a frame, a certain part of the mesh has gone wrong of the space that you're playing in. So these things will happen. The good thing is, if it doesn't work out, we may not use the output. We don't need to use the output if it doesn't work out. But here's the thing. With more and more data being collected, with more and more algorithms which are designed for different industries being customized for our industry, we will eventually reach a position where the amount of noise that we'll see will reduce. As Sir alluded to early on, AutoCAD was initially made for mechanical engineers, and we kind of customized it through, or rather Autodesk made it customized for us. Similar things will happen with AI algorithms. Also, when the process of regeneration or iteration becomes automated, your or our lookout would be in representing our input in a manner that the noise is reduced or noise is the least, or making an example 3D or the data set with which we are working, be it a data set of 3D models, should not include bias as much as possible. So the quality that makes you a great architect right now will slightly change or get modified when you get into such processes where it's more about curation of information. It's more about curation of data. That becomes the primary focus from the kind of things that we worry about at this moment, given the traditional sense of designing.
Thank you for answering the question. So basically, when I talked about like sort of like when you explain glitches, and it's a great example. So what I was talking about is like we feel these are glitches because we actually don't understand them, or maybe like we sort of like think these are not. But these are the things that are like sort of beyond our control, and that's what make them like sort of like great. So what I was talking about was like how to like when we talk about art and everything, like sort of like Monet and all these people at one point must have been considered sort of a glitch only, like they were different and everything. So like basically how to like get more noise in terms of so that it can basically help us look at designs in a different way rather than like sort of like discarding them. So that's
Yes, which is where I would take your attention back to the image of the portrait that was auctioned, and it was signed with the quite literally the optimization algorithm which addresses your question. That is, how do we make something not so similar to pre-existing examples so that it's not considered a copy, and yet not make it too abstract, right? Two opposing forces interacting with each other. And even if you don't get into the business of AI or computation, that is a question that plagues the best of artists, the best of architects. Even if you use the most traditional mediums, even if you just doodle your things, even if you use paint and brush as an artist, these are the kind of questions, fundamental philosophical questions that plague all creators. Now, the ones that developed the paintings used a log formula to address that question. When we do it manually, we rely on our intuition to address that question. When we talk about paper writing, that takes the form of plagiarism checkers. So different applications have different means and methods to answer that question. I don't have a ready-made answer for that. I would say that that is an open-ended question. We will wait and watch as to what is the best possible way to address that issue of being different enough yet being similar enough to be familiar. If I'm talking about making a building, I can't randomly put up an inverted pyramid, right? Because people don't relate to it as a building. So it needs to be similar enough yet dissimilar enough to be considered something new. So I don't know. My guess is as good or as bad as yours at this moment. There's no clear answer to that.
Okay, thank you, Rohan, for the question, and thank you, Joy, for the answer. I think so. Mehta sir, would you like to give a few like the finishing comments for today's topic or the presentation? I think that after that we can wrap up the webinar for today. So, sir, are you there? Okay. So I think with this we can wrap up today's webinar. Yes, sir, are you there?
Yeah. No, I think
Okay.
it was a wonderful experience. Joy presented it wonderfully well. And I think a lot of takes from here to carry forward. So on the whole, I think wonderful. And Joy, you can come in anytime you want to further it for the betterment of students or anything, any idea you have to carry it forward, do contact Tushar. I think we'll take it up. Thank you. Thank you very much. I think it was a wonderful
Thank you for the
presentation.
kind words, sir.
Yeah.
Okay, so thank you so much, sir. And with this, I would like to thank Joy for his wonderful representation and all the participants for being here today. Just as a reminder that in case you missed part of the presentation or the previous webinars, you can always check the recordings. They would be on the Peria School of Architecture YouTube channel. And we would also be soon announcing summer schools and more webinars as well. And the information would be relayed to you very soon. Thank you all for being here, and please have a good day. Thank you.